So calculating probabilities involving a normally distributed random variable. So our normally distributed random variable here is BMI. We have the mean is 24.5, standard deviation is 3.2. Find the percentage of U.S. men with a BMI between 23.1 and 25.8. 23.1 and 25.8. So what are we looking for? We're looking for the probability of a random U.S. BMI, random U.S. male BMI, that's X, between, on the left, 23.1, that's going to be the lower bound, and an upper bound of 25.8. Right, you want the BMI X to be between those values, 23.1 and 25.8. Okay, let's just graph this one. Let's graph this. Let's draw a picture so we have an idea. So you have your normally distributed random variable X, which represents BMIs, and has this density curve. And in the center, you got what, 24.5? That's the mean, right? That's the average. So to the left of that, you got what, 23.1? And to the right of that, you got what, 25.8? And you want your X, you want your random BMI to be in between those. That means you got to find the area under this curve between 23.1 and 25.8. So basically my strategy is I'm going to convert this over to a Z distribution. A Z distribution, a standard normal distribution. At 24.5 is going to convert over to 0. And X is going to convert over here to a Z-score. And 25.8 is going to convert over to a number. And 23.1 is going to convert over to a number. And we're going to find the probability of getting a Z-score between those two yellow numbers. That's the idea. Okay, so how do we do that? Well, first, we got to convert. Let's convert 25.8, X equals 25.8, to a Z-score. So I'm going to use my Z-score formula. Z equals X minus mu divided by sigma. Okay, in this case, X is going to be 25.8. Mu is the mean, 24.5, that doesn't change. Sigma is the standard deviation, 3.2, that doesn't change. Let's plug it in and find out what that Z-score is for 25.8. 25.8 minus 24.5 divided by 3.2. You always take your Z-score to 2 decimal places. That's going to be what? 1.3 divided by 3.2. Okay, where's my calculator? Calculator, where are you? Can't find it. There it is. 1.3 divided by 3.2. 2 decimal places, about 0.41. 0.41 roughly. All right, then you got to do the same thing for 23.1. You got to convert 23.1. It's your left bound to a Z-score. Convert X equals 23.1 to a Z-score. So the same formula, Z equals X minus mu divided by sigma. This time X is 23.1. Mu is still the mean of 24.5 and sigma is still the standard deviation of 3.2. I'm going to plug those in. Wrong color. Yellow, there we go. 23.1 minus 24.5 divided by 3.2. How's that turn out? 23.1 minus 24.5. It's negative 1.4. Divided by 3.2. It's about, remember, 2 decimal places, negative 0.44. Negative 0.44. Okay, so here we go. This is equal to the probability, I'll just leave this out here, probability of getting a red z-score, x converted to z, between, so 23.1 converted to minus 0.44, minus 0.44. No, it didn't draw too well, did it? Come on. Okay, so 23.1 converted to minus 0.44, and 25.8 we said converted to 0.41. So I'm going to replace 25.8 here with 0.41. Okay, so we're trying to find the probability of getting a random z-score between negative 0.44 and 0.41. So we're talking about this green area right here between negative 0.44 and 0.41. So to find that probability, we take the probability of getting a random z-score less than the right number, 0.41. And then subtract the probability of getting a random z-score less than, yes, less than negative 0.44, the lower bound. So all I have to do, I have to look up 0.41, write that number down. Then I'm going to look up the number negative 0.44 in my table, and I'll write that number down. And I subtract the larger minus the smaller. Here we go. Okay, I forgot what numbers I'm looking up. Let me go back and look. 0.41 and negative 0.44. Okay, 0.41. It's in the positive table. Here we go. .41. So that number is 0.6591. 0.6591. 0.6591 minus, okay, now we're going to look up negative 0.44 in our negative table. Where's the negative table? That's it, right? I forgot what I'm looking at. Was it negative 0.44? I think it was negative 0.44. Yes, negative 0.44. Where is that? Negative, come on, write. It's not writing. There it goes. Negative 0.44. Put those together and you find the area to the left of negative 0.44. .3300, 0.3300. Come on. There it goes. 0.3300. Okay, so I got to subtract those. I take 0.6591 minus 0.3300. And you get 0.3291. Now, remember we want a percentage, so we're going to take the decimal to the right. We're going to get 32.91, and we're going to slap a percentage sign on the end. So we can say approximately 32.91% of U.S. men have a body mass index between 23.1 and 25.8. All right, let's do one more. Number 6. Number 6. What percentage of U.S. men have a body mass index between let's make it a pretty broad range. 21.5 and 27.5. You don't have to draw pictures, but I'm going to draw one just for illustration. And here's your density of your BMIs, your X's. And in the middle, you have what? 24.5 is the mean. So on the left of that, you got 21.5. And on the right of that, you have 27.5. So what you want is an X value, right? You want an X value in between those. You want an X in between, a BMI in between. So to find that probability, or that percentage, we're going to find that area there in between 21.5 and 27.5. So the way I'm going to write that, this is going to be the probability of getting an X value, a BMI, in between 21.5 and 27.5. The first thing I'm going to have to do, I'm going to have to convert from X values to Z-scores. I'm going to convert 27.5 to a Z-score. So I'll use my Z-score formula, X minus mu divided by sigma. Here X is going to be 27.5, mu is going to be the mean of 24.5, and sigma is going to be the standard deviation of 3.2. So when I plug this in, I get 27.5 minus 24.5 divided by 3.2. It's going to give me, what's that going to give me? 3 divided by 3.2. Let's see what that is. 2 decimal places, remember? 0.94. Okay. Now let's convert 21.5 to a Z-score. Convert X equals 21.5 to a Z-score. So I got Z equals X minus mu divided by sigma. X is 21.5. Mu is the mean, 24.5. Sigma is the standard deviation of 3.2. Let's plug in. (21.5) minus 24.5 divided by 3.2. So if we do that, we're going to get Z is negative 3 divided by 3.2, which is going to give us a yellow Z-score of negative 0.94. Okay, so we got 0.94 and negative 0.94. So if I'm drawing a picture, you don't have to draw pictures. I'm going to draw a picture. I convert my distribution of X values, BMIs, into Z values. So 24.5 gets converted to 0. 27.5 gets converted to 0.94. And 21.5 gets converted to negative 0.94. So we want a Z-score in between, right? In between. That didn't right. There it goes. Oops, it's all messing up now. Shoot. It's all falling apart. There it goes. Yep, so we want a Z-score in between negative 0.94 and positive 0.94. So So that's the area in green we're looking for, the area between negative 0.94 and positive 0.94. So writing this as a probability, this is the probability of getting a random z-score in between negative 0.94 and positive 0.94. In other words, using our formula, the probability of getting a random z-score less than 0.94 minus the probability of getting a z-score, yes, less than minus 0.94. So we look up 0.94 in our table, positive table, and then we'll look up negative 0.94 in our table. Subtract. Come on, can we, there we go. So we want to be in the positive table right now. This is not working. Okay, let's go in the positive table. Let's look up 0.94. .94 right there. That gives you your area to the left of 0.94. I'll zoom in on that a little bit. It's 0.8264. Minus, now we're going to look up negative 0.94 in our table to get the area to the left of that. Okay, scroll. Yeah. There we go. We're in the right table now. Negative 0.94. Here we go. Negative point. Come on. Negative 0.9 with a 4 there. It's going to give you an area of 0.1736 or a probability of 1.736. 0.1736. I think I said that right. Let me go back and check. Yep, 0.1736. Okay, so you're going to subtract those numbers. 0.8264 minus 0.1736, and we get 0.6528. Okay, so this is finding probabilities. Oh, wait, did I finish this problem? I'm not quite finished, right? We wanted the percentage of U.S. men that had a body mass index between these values. So we want a percentage. So we've got to move the decimal 2 to the right, right? We get 60.